Hi, welcome back. Thanks for joining me. I'm Claudia Carranza. We are working on section 8.6, the law of sines and cosines. Now, so far in our study of triangles, we've been working with some trigonometry, which means the measure of three-sided objects, triangle measure. But so far, trig has only allowed us to do triangle measures of right triangles. That's not useful. I mean, if this stuff is supposed to be triangle measure, it should be like all triangle measure and not just right triangle measure. The law of sines and cosines allows us to use trig, which right now is based only on right triangles, on triangles that are not right, on triangles that are acute triangles or obtuse triangles. And it allows us a way to calculate measures in those not right triangles. Let's see how we do that. Let's talk first the law of sines. Back in lesson 8.4, we used the trigonometric ratios to find the side lengths and the acute measures in right triangles. For non-right triangles, law of sines to the rescue. Theorem 810 is the law of sines. And basically what this law is giving us is that the sine of one of the angles in a ratio to the side opposite that angle is going to be in proportion for all those other ratios. So ratio of one angle to its side is equal to the ratio to the sine of another angle in a ratio to its side, and so forth. We can use the law of sines to solve any triangle if we know the measures of two angles and any one side. Let's do this example. I'm going to get some highlighting going so that we can see what we're working with. First off, I have an angle measure here at A, and this is the side opposite that angle. And then I have this angle here at C, and I have the side opposite it. So I'm going to go ahead and write that as a proportion. So I have one of my angles. Here's one of my proportions. So I have the sine of one of my angles. We'll say that that's the blue angle, and underneath it is going to be the measure of the blue side. And then on my other fraction, I'm going to have the sine of the other angle in my triangle. This one I colored red. And then under it is going to be the measure of the side opposite that angle. Okay, so here's an angle, and here's the angle that I colored in blue, 21 degrees. So I'm going to put 21 here as degrees. And then the side opposite this angle is here, and that's given to me by the variable x. So I'm going to put an x. And now I'm going to look at the other angle. The other angle is this 97 that I did in red. So I'm going to write 97 here as my angle measure. And then the side opposite that angle is this one, 16. And now this becomes just like what we did in chapter 7.1 with proportions. I have two fractions equal to each other. I have a proportion. I can cross multiply and solve. So the extremes multiplied together, that's sine 21 times 16. And that gets written as 16 sine of 21. It means 16 times whatever the number sine 21 is. And I don't know what that number is right off the top of my head, but I have a calculator that does trig functions and it can tell me what that decimal is. So those two multiplied together is equal to this denominator and this numerator. The means is what we call them. And it's going to be x times the sine of 97. And again, I don't need to write the multiplication symbol between those two things because it's implied. We don't want any extra like x's in there because that would look weird. I guess I could put the points in there if I really wanted to, but I don't have to. This says x times the sine of 97. Now the sine of 97 is just a number. My calculator can give that to me, which I'll do in the moment at the end. I want x by itself. I want to isolate it. In order to isolate it, I need to get rid of this multiply by sine 97. Well, what's the opposite of multiply? Divide. So I'm going to divide both sides. The question is, what do I divide it by? The answer is, what am I currently multiplying x by? I'm currently multiplying x by the sine of 97, so I'm going to divide by the sine of 97. Remember, this is just a number, probably not 0. Let's stick that in our calculator real quick just to make sure it's not 0, because we're not allowed to divide by 0. That breaks algebra and the world ends. Not really, but sine 97. Sine 97 is not 0. So if you can see there on my tiny little screen, it's not a 0, it's some decimal point. All right, these cancel, and that leaves me with x is whatever I get when I take 16, I multiply that to whatever number the sine of 21 degrees is, and then I divide that product by the sine of 97. I'm going to go ahead and take a moment and find the numeric values for these, because my calculator is not smart enough to do this all in one step. Here was the number that my calculator gave me for the sine of 97. And I'm going to take that out to 4 decimal places, because that seems like that's enough precision. Sine 21 is the next one I'm doing, and my calculator gave me this decimal. Again, there's a lot of numbers on my screen, so I'm going to go ahead and just stop this at 4 decimal places. I do have to do some rounding, and now these are just numbers that I know how to deal with. So I'm going to go ahead and multiply that top number by 16, and then divide my result by the thing in the denominator. And when I'm done, I get this decimal out to 4 decimal places. Now, I do need to check to see what precision this wanted at the end. So I'm going to zoom out a little bit, and it wants the nearest 10th. So I need to round this to this decimal place. The number behind it is definitely bigger than 4. And so x is going to be 5.8. All right, we can do that same thing here. Here we go. Here's another setup, but this setup is slightly different. Let's find out how. Here's an angle, and here's a side across from that angle. So far, so good. Here's the other angle, and here is the side opposite that. Oh, I don't have any information about this side. And having information on the side isn't going to help me figure out this red one, which is what I'm interested in. What I really need is I really need to know the measure of this angle. So how can I do that? Well, if I think way back to chapter 4, I think it was, when we were first learning triangles, we had this theorem called the triangle angle sum. And the triangle angle sum said that if I were to take all 3 angles in a triangle and add them together, I would get 180. So I'm going to use that fact to help me figure out what the measure of this missing green angle is. That way I will have an angle and the side across from that angle to set up my proportion and solve for the unknown. All right, so I'm going to take 180 and I'm going to subtract off the angle measure in red, which is 45, and the angle measure in blue, which is 73. And when I go to my calculator and I do that subtraction, I get 62. So the measure of my green angle is 62 degrees. And now I can set up my proportion. I'm going to set up my proportion using the information with the green and the information in the red. So let me go ahead and set up my proportion. The top is always going to have the sine and the angle information. The denominator is always going to have the side opposite the angle that I listed in the top numerator of the fraction. All right, so the green angle's measure is 62, and the side across from this one is 10. And then in this other ratio, the angle that I'm looking at is this 45 degrees. Again, picking this one because I actually have some information about the side opposite that angle. Yes, a variable counts as information. It counts as I'm interested in knowing the measure, even though I don't know the measure right now. That's good enough information for us. All right. We're going to go ahead and cross multiply again. So this is just solving a proportion. I'm going to cross multiply. Sine of 62 times x gives me x sine 62. That's how this is read. And it means x times the sine of 62. Right, let us multiply these other two pieces of my cross multiplication. That's 10 times the sine of 45. That gets written as 10 sine of 45. And that means 10 times whatever the sine of 45 is. Trying to solve for x, I notice that it is being multiplied to the sine of 62. And so I'm going to divide both sides by the sine of 62. I know this looks weird, but remember the sine of 62 is just some number. It's some weird decimal number. And so I can divide by it. And now I can put this in my calculator. Again, you're going to see me do this in small steps because my calculator not quite smart enough to do all of this in one step. So I'm going to do them in pieces. And I'm going to take my trig functions, those decimals that my calculator is going to give me, and I'm going to go out to the fourth decimal place. Oops. Let me get that value. Nine. And now I'm going to do this division here. 7.0711 divided by 0.8829, and my results is 8.0089. And then I'm going to zoom out a little bit so that I can see my directions, and my directions say to the nearest tenth. So I'm going to round this to the 10th decimal point. That's this one. It's currently a 0. I look one past it, I see 0 again. And so I'm not going to change the value of the number I'm rounding to. 8.0 is the measure of x. At the top of this lesson, we talked about there being two different ways. In fact, the name of this lesson has two different laws, the law of sines, excuse me, and the law of cosines. All right, so now that we've done law of sines, let's look at the law of cosines. Now, the textbook in my notes gives me all of these and it looks super confusing. So I want to give you a slightly easier way to think about the law of cosines. The law of cosines formula says this: I'm going to take a side length and I'm going to square it. And that result is going to look a lot like the Pythagorean theorem, where I'm going to take the other two sides, square them and add them together, but I'm going to subtract off this real special term here. And this term is 2 times those two side legs multiplied together, and it's the same as these, times the cosine of an angle. Now, the cosine of an angle, the angle is important. This angle, whichever angle we decide to look from, or that we have information about, or that we care about, it has to be the angle that this side is opposite of. So whatever side that you're squaring by itself, that side has to be opposite to the angle we're taking the cosine of. So these two positions are very much related to each other, and one depends on the other. For the other two sides, it really doesn't matter what order you've put them in. You just want to get them in and make sure that you're representing both of the other two sides. All right, let's zoom in. I'm going to have my formula up here where you can see it, and I'm going to have my triangle down here where we can reference it. All right, going to look first for the angle measure. So here is the angle that I have a measure on, which means this is the side that's opposite that angle. Then the other two sides, one becomes the green angle, one becomes the blue angle. And no, we really don't care which one you pick to be which. So there's my setup. All right, I'm going to take this format and I'm going to copy in the information that I have. All right, this is a side. So that's this side across from the angle that I have information on. So I'm going to write X, and that value is being squared. All right, the next ones are just the other two sides in whatever order, and those have been squared. So I'm going to go ahead and write those squared, and I am going to match my colors to my figure just to make it a little easier for us to keep track of where I'm writing things. Here's the other side. I'm also squaring that one. And now is the big weird term that I am dealing with, which is 2 times the sides of the legs multiplied together times the cosine of the angle. All right, so these are the same sides that we just finished copying here. So I'm going to use the same colors and the same numbers. And now the angle is this original angle that I saw at the very beginning. So I'm going to put that angle measure right here. And now I have this equation that I'm going to solve for X. Spoiler alert, the X is already by itself, except it's squared. So I'm probably going to have to get rid of that square power sometime soon. I'm going to go ahead and just get started on some of this calculations. Please feel free to pause here if you want, or work this out on your own as I ramble and talk quietly. Just make sure that as you're watching me work on this, that you understand where I'm getting these numbers from. If you're not sure, pause the video and take a moment to take a look at it and see if you can't figure out where these numbers are from. If you still can't, leave a comment in the doobly-doo below. I will be happy to take a look at that and answer as soon as I can. All right, so I've already squared everything. I'm now going to add. I do not know how to do 81 plus 200, 121 in my head. My answer is 202. And now I'm going to go ahead and multiply the 18 and the 11 together. And I get 198 out of my calculator. My mouse handwriting has gotten so bad again. All right, there it is. Now, I cannot subtract this 198 from the 202. I can't do that because this 198 is being multiplied to this cosine of 28. So I need to do this multiplication first, and thank goodness I've got a calculator that can help me out. So in my calculator, I'm going to go ahead and type 198 times the cosine of 28 and see what I get. My calculator gives me this number, 174.82. My next number is a 3. I'm trying to decide where to round to. This seems like enough precision for now, especially since I've been asked to round it to the nearest 10th. I'm going to go ahead and leave it here. This seems like it's precise enough. All right, now I can subtract these two values. I'm going to go ahead and do that subtraction really quickly. Now, as you're doing these trig functions, as we've mentioned previously, you want to make sure that your calculators are in degree mode. If you're using a fancy TI Inspire, you're going to want to check, you want to check your settings option in a little school calculator like this TI-30 that I'm rocking right now. There's probably some sort of setting somewhere, a button that you can push to go from degree to radian. If you're using your phone, I don't really know how you would change it because it's dependent on what kind of phone you're rocking. So if you're rocking an Android, the way that you go from degree to radian is going to be different than how you would do that on an Apple. All right. The last example that we have for you really here today is what happens when you're trying to find an angle measure. I know the side measures on this triangle, I know all three of them, but I do not have the angle measure. Once again, I'm going to zoom in nice and tight on this triangle and I'm going to start putting in some colors. Before I put in some colors, however, I'm going to create my formula and I'm just copying from the formula that I had at the top of the screen. And I'm using my boxes because I know that's where numbers are going to go. And I'm going to color code my triangle so that I know what is going to go where. The only thing that's important to know is that the trig function is always only going to accept some sort of angle measurement. So don't try to stick a side measurement in here. It'll mess things up. All right, I'm just going to start color coding here real quick. Remember that what you're looking for is you're looking for the angle and the side opposite that angle. And then the other two sides are just the other sides that I don't have any angle measure information for, and they just go wherever we want them to go. All right, the measure of the angle is X. The measure of the side across from that angle is 8. The blue side we marked as 6. The green side is listed as 3. And there's my equation. Remember, between all of these boxes, I have a multiplication. All right, and now I'm just going to do some arithmetic here until I can get this, down. I wrote 64 squared. That is not the same as 8 squared. 8 squared is 64. Wow, my screen went blank. Hello. I think that my program there was laughing at me for saying that 8 squared is 64 squared. Thank you for making fun of me, computer. Really appreciate it. I'm just going to keep right on chugging. 2 times 6 is 12. 12 times 3 is 36. And then cosine of X. This is really hard because now there's a delay when I write on my pencil. I'm gonna add these two together. I think that's gonna be 45 minus 36 cosine of X. Cannot subtract the 45 and the 36 from each other, so I have to do the inverse of the addition that's sitting here. I don't see an addition, it's invisible, but I know it's there. 64 minus 45. I can't do that in my head, so I'm going to go to my calculator. My calculator tells me that that's 19. So 19 equals negative 36 times the cosine of X. I want the cosine of X by itself right now because I want to find a way to break the cosine off of the X. And I can't do that when there's a number multiplying to it. These cancel. I'm left with 19 divided by negative 36. My calculator says that that is a negative 0.527 will do 8 equals the cosine of X. Now in the last section 8.4 trigonometry, we discovered that in order to break the trigonometric function off of the angle measure, in order to discover what the measure of that angle is that's generating this number, we have to apply the inverse trig function. The inverse of cosine is called the inverse cosine, and it's written this way. It's written as COS for cosine, and then what looks like a little exponent -1, but that -1 isn't being applied to a number, so it's not an exponent -1. It's being applied to the name of a function, the name of something that we do to a number. And so because this -1 is being applied to the name of the function, it means the inverse of this function. All right, so that means in order to calculate the value of x, I need to take the cosine inverse of -0.5278. And when I put that in my calculator, I will get out an answer for x. Taking a look at my directions, it wants it to the nearest degree, so that's the nearest whole number. On this calculator, the TI 30X series, you'll need to push the second button and then the cosine button to get cosine inverse. On an Inspire, you hit the trig button and it brings up a menu of everyone, and then there's a few other calculators. If you're using your phone, I think when you turn it sideways, there's the little 2 arrows that's like the shift key. And according to my calculator, I get 93.0254, a bunch of numbers. I want it to the nearest degree, and so I'm rounding and I get 93 degrees as the measure of this angle right in here to the nearest degree. The last thing to say about this is that the law of sines and the law of cosines helps you solve a triangle. And all that solving a triangle means is that you're finding all the different measures of all the different angles and sides in a triangle. As I look at this triangle, I notice it already has all of the side measures. So the only things that we're missing are the angle measures. Thankfully, the law of cosines, just as you saw done here in example 4, can help us out. All right. If you'll follow me on Instagram, I will get this all worked up and I will post some pictures there for you of how this is all worked out. Might be a picture of my whiteboard, might be pictures out of my notebook. You just never know, but please do follow me on Instagram. Leave a like and a subscribe if you'd like to on this channel. Like the video, leave me a comment. Let me know if I've confused you in any way, shape, or form. It is with your wonderful comments that I get to be a better teacher each and every single day. Thank you for stopping by and learning with me today. I greatly appreciate it. And I look forward to learning from you from the comments that you leave me down below. Thanks again. Have a wonderful day. And to my lovely students who are watching this, thank you very much. Don't forget to turn in your homework for me so I can get those graded and turned in for you. That didn't make sense, but I'm going to leave this and not edit it anyway. Thanks again. Have a good one. We'll see you in class. Get some sleep. Do your homework. Catch you later. Bye.